Introduction. Sweep AI is an AI-powered junior developer for GitHub that turns written issue descriptions into code changes. In practice, a user writes a GitHub issue, e.g., add type hints to this file, and Sweep autonomously searches the codebase, generates the needed code, and opens a pull request for review. As one security profile notes, Sweep is an AI code assistant that turns GitHub issues into GitHub pull requests. In other words, Sweep automates the mundane work of fixing bugs, writing tests, updating docs, and adding small features, so developers can focus on architecting the core product. Sweep was launched by founders William Zhang and Kevin Liu, both ex-Roblox engineers, through Y Combinator in 2023. It is designed for teams and open-source projects that want to move fast on non-critical improvements. For example, one of the demo issues was simply add a banner to your web page, which Sweep handled automatically. By design, Sweep emphasizes small to medium tasks. It excels at one-file bug fixes or feature requests, but not large refactors or architecture overhauls. In short, Sweep promises to handle your tech debt by converting simple issues into tested code commits. How Sweep works. Sweep's core process follows these steps. Contextual code search. When an issue is created or flagged, Sweep scans the repository to gather relevant code snippets. It uses techniques like dependency graph analysis, vector search, and code chunking to summarize the existing code base for the LLM, large language model. This ensures Sweep has context, for example, related functions or data models, to answer the question posed by the issue. Planning changes. The AI next generates a structured plan for the code changes. Engineers found that asking the LLM to output an XML or bullet-formatted plan, e.g., which files to modify or create, is effective. The Sweep team notes they use XML tags and prompts, so the model produces a clear list of planned edits. Code generation. Using the plan and gathered context, Sweep then instructs the LLM to write new code or modify existing code. All code is templated into the repository, with the bot making edits one file at a time. For example, if the plan says add a banner HTML element, Sweep will edit the relevant HTML, CSS, JS file accordingly. Testing and formatting. Crucially, Sweep automatically runs the repos test suite and format checks on the new code. Only if tests pass and linters agree does Sweep proceed. The PyPI documentation highlights that Sweep runs your unit tests and auto-formatters to validate generated code. This built-in self-healing ensures that most trivial mistakes are caught early. In fact, Sweep can even automatically fix simple test failures or formatting issues before creating the PR, reducing iteration time. Once validated, Sweep pushes the changes to a new branch and opens a pull request PR on GitHub. It attaches a description and any plan notes, then waits for human review. If reviewers leave comments or request changes, Sweep can even iterate. The team confirms that Sweep will continue the conversation, replying to comments and updating the PR until it's merged. In summary, Sweep acts like an assistant agile developer. You spin up a ticket, and the bot does the coding on that ticket, addressing comments as needed. All of the above happens via a GitHub app or CLI. Developers install the Sweep GitHub app onto their repository, grant it access, and then Sweep will monitor new issues for its trigger. See setup below. This process is largely editor agnostic. While Sweep offers IDE plugins for JetBrains, VS Code, etc., the issue to PR automation works entirely on GitHub itself. Setup and requirements. Getting started with Sweep on a project involves a few key steps. Install the Sweep GitHub app. A repository administrator must install Sweep from the GitHub Marketplace. On the Sweep GitHub app page, you click Install and select the target repo S. This gives Sweep permission to read issues, edit code, and open PRs. Triggering issues. By default, Sweep only acts on issues explicitly marked for it. The recommended workflow is to prefix issue titles with Sweep or add a Sweep label. This prevents Sweep from responding to all issues indiscriminately. For example, creating an issue titled Sweep Add Type Hints to GitHub-utils.py will trigger the bot, whereas a normal issue without the prefix will be ignored. .sweep.yaml configuration. Advanced usage may involve a configuration file in the repo root. Here, teams can whitelist or blacklist directories, fine-tune code search, or enforce code-style rules. Setting this up requires some initial effort. A review site notes that Sweep requires upfront investment in configuring .sweep.yaml and GitHub Actions workflows for best results. This might include specifying Python package settings, environment variables, or custom test commands. Language and tech constraints. Sweep focuses on GPT-4 capabilities, so it supports any language GPT-4 can generate. While the team focus on Python, they explicitly list support for JavaScript, TypeScript, Rust, Go, Java, C, C++, etc. Very large monorepos, tens of thousands of files, may slow Sweep down. The documentation warns it struggles with gigantic repos over 5,000 files, unless some paths are excluded. Also, Sweep cannot edit binary non-code assets, e.g. images or UI mocks at all. Security and compliance. Because Sweep integrates deeply with code, teams should consider security. Sweep advertises enterprise-grade compliance, it's SOC 2, HIPAA, and PCI compliant, and claims a privacy-first model with no long-term code retention. In practice, Sweep transmits code snippets to its LLM backend, but does not store your code after generating a PR. Companies typically treat Sweep like any other GitHub app. It acts under OAuth, and its actions appear in the GitHub audit log. Overall, the initial setup is straightforward for developers, but may require coordination with your team's security and CI/CD processes. Once installed, opening a marked issue is all that's needed for Sweep to take over. New users are encouraged to start with a trivial example, e.g. ask Sweep to add type hints or improve test coverage in a single file, before moving on to larger tickets. Safety controls and monitoring. To ensure quality and security, teams employ several controls around Sweep's usage. Human-in-the-loop reviews. No Sweep-generated PR should be merged blindly. The intended usage is that experienced developers must review every Sweep PR. As the co-founder William Zhang remarks, senior devs will read the code, identify missing edge case handling or tests, and request changes if needed. Sweep is not a lights-out robot, but a coding assistant. Human oversight is critical. Most teams gate PR merging on normal review processes, treating a Sweep PR like any other. Label-based activation. By requiring a Sweep, prefix, or label, teams ensure they control which issues invoke the bot. This gating prevents unexpected automation. For example, Sweep won't fix security or performance issues unless explicitly asked. It also lets product owners triage tasks. They can choose which bug reports and feature requests are routine enough for the AI to attempt, and which need direct human work. Automated testing. Since Sweep itself runs your tests before submitting a PR, many classes of errors are caught early. If a change fails tests or linters, Sweep will not finalize the PR. In fact, Sweep aims to self-heal after test failures. The team notes it can automatically fix failing tests and compilation errors during generation. This built-in CI check acts as a safety net, so the PR that lands has already passed the existing test suite. Iteration via comments. In practice, Sweep PRs undergo normal review iterations. If a reviewer leaves comments or adds new tests, Sweep can respond by making follow-up commits to that PR. The founders confirm that Sweep handles failing GitHub actions and comments by automatically updating the PR until it passes or the conversation is done. This means the bot learns from reviewer feedback in real time, rather than requiring the user to start a new issue. Limiting scope of changes. The Sweep configuration can explicitly block certain directories or files. For instance, you might exclude JavaScript libraries or auto-generated code from Sweep's index. The PyPI docs warn that Sweep works best when pointed to a file, and struggles with broad goals like refactor entire codebase from X to Y. By setting policies, for example, only allow Sweep on backend Python files, not on infrastructure config, teams can keep the agent focused on bite-sized tasks. In summary, teams treat Sweep as a powerful but imperfect teammate. It automates the routine, but the humans still set direction and quality standards. By using labels, requiring reviews, and leveraging Sweep's own test running rules, organizations keep a tight feedback loop. As Kevin Liu of Sweep explains, for now, it's often enough if the bot works 90% of the time on simple tickets. The remaining edge cases are caught by human reviewers or additional comments. Strengths and weaknesses. Strengths: Sweep shines on small developer chores and straightforward bug fixes. It is particularly adept at code chores, adding type hints, formatting code, writing documentation, or filling in missing test cases. The Sweep docs explicitly mention handles DevX chores like adding type hints, improving test coverage. Isolated changes, single file edits, or adding new functions based on clear issue descriptions. For example, asking, add a new API endpoint that returns user info, can succeed if the repository has obvious analogous code. Parallel issues. Because Sweep is fully asynchronous, a team can open many Sweep issues at once, and the bot will work on all branches in parallel. This is in contrast to a human dev, who can typically focus on one task at a time. Rapid prototyping. For non-critical code updates, UI tweaks, minor algorithm adjustments, Sweep can whirl through tasks much faster than a person would have to type them out, as long as the LLM has the right context. Learning from feedback. If a generated PR has problems, the review cycle teaches it immediately. Sweep's chat and comments capabilities let it refine its code generation on the fly. Weaknesses. The bigger or fuzzier the change, the worse Sweep performs. Notable limitations include large refactors. Anything touching more than a few files, roughly greater than 150 lines across 3+ files, is a red flag. The documentation warns that large-scale refactors are not recommended. For example, asking Sweep to migrate the codebase from Django to Flask, or to rewrite a data model from scratch, is beyond current AI reliability. Ambiguous or underspecified issues. Sweep depends on clear prompts. Vague issues, improved performance, often lead to incomplete or misguided PRs. The team and reviewers note that poorly specified tickets result in incomplete or misdirected implementations. Users must often refine their issue text or use Sweep's Slack chat interface to clarify intent before a PR is generated. Context gaps. In very large or complex projects, Sweep's context window may miss important information. It chunks code for the LLM, but if the relevant files aren't indexed, or the issue depends on cross-cutting architecture, the output can be wrong. This is why teams restrict Sweep to smaller submodules or exclude seldom used areas. Non-code assets. Sweep cannot handle changes to images, style sheets, or onboarding flows. It only edits text files. GUI or design changes still require human hands. Edge case logic and bugs. While Sweep runs tests, it can still introduce logical errors that tests don't catch. That's why the human review step is crucial. The team expects that about 10% of Sweep's output may need tweaking. One co-founder put it bluntly, 90% of the time is fine for straightforward tasks. The remaining 10%, edge cases, typo corrections, extra error handling, get fixed in code review. In practice, users have found Sweep most reliable for small bug fixes, typing improvements, and repetitive refactors. Tasks like rename all occurrences of a variable in one file, or add input validation to this function are well suited to Sweep. By contrast, architectural changes, database migrations, or designing new systems should still be done by experienced developers, with Sweep possibly assisting in isolated subtasks. Case studies and observations. Because Sweep is relatively new, there are few published formal case studies. However, several public comments and early user reports give insight. Explore repositories. In Sweep's own demo, an example public repo for testing, an issue to add a banner to the web page was fully resolved by the bot, demonstrating its capability on a trivial front-end change. This example shows a one-file change working end-to-end. Open source use. Some smaller open source projects have trialed Sweep. For instance, one project reported using Sweep to beef up test coverage and add missing type hints across Python modules. They found that most of the generated changes were accepted, though reviewers had to add a few extra tests and docs comments. Exact acceptance rates are not publicly released, but users anecdotally say most of Sweep's minor fixes pass review with minimal edits. Developer feedback. On forums like Hacker News, deputies have tested Sweep. Common praise is that copywriting boilerplate or small functions is quick and surprisingly accurate. Critiques often point out that Sweep can go off track if an issue requires deep reasoning or creative problem solving. One Hacker News commenter noted that Sweep works way better if there are comments in the code, because comments match search queries well, and predicted weaker performance on bleeding-edge or poorly documented frameworks. Post-merge bugs. Because Sweep runs tests before merging, obvious bugs are rare in merged code. In early experimentation, some projects did find occasional logic mistakes after merging, but these were usually trivial, off-by-one errors, missing null checks, that a human would also catch on review. The consensus is that Sweep's post-merge bug rate is comparable to what you'd expect from rapid human-generated code changes in routine tasks. In summary, public feedback suggests Sweep is very effective at small, well-defined tasks. And its pull requests often get accepted quickly, provided a developer still checks the work. Most users stress the importance of review. No major failures or security incidents have been reported from using Sweep, likely because teams are cautious about what they ask it to do. A conservative workflow, label triggered issues, senior reviewer on duty, keeps risk low. Getting started and next steps, or developers or non-coders interested in trying Sweep, the first steps are: install the app. Go to the Sweep GitHub app page and add it to your repository. You can start with a public test repo if you just want to experiment. Try a simple issue. Create a new issue with the prefix Sweep, or add a Sweep label, and describe a trivial code task. For example, Sweep add type hints to function compute stats in file utils.py, or Sweep fix typo in README and update docs. Review the pull request. After a minute or two, Sweep will open a PR. Examine the changes. If it nailed the solution, great. If not, leave review comments. Try asking it to add missing pieces, e.g., please add a null check for this parameter. Sweep will update the PR automatically. Iterate. As you get comfortable, you can issue more complex tickets or adjust Sweep's settings. Monitor the results and give feedback. Since Sweep can process multiple issues at once, you can scale up by batching simple tasks. Monitor and refine. Check your repository activity. All Sweep's commits and PRs will be labeled by the Sweep user bot. Your team should track these like any contributor. Over time, you'll discover which types of issues you trust Sweep with. Remember, Sweep is a tool to assist. It speeds up routine work, but doesn't replace human engineers. The ideal next step in your product workflow is to delegate repetitive chores to Sweep, so your developers can tackle the harder problems. As FAQs and user discussions have noted, the low-hanging fruit automation, tests, refactors, doc updates can shave hours off development time. For a new user, the most important thing is just to experiment. Pick one small issue, give Sweep a try, and see how it performs. Conclusion: Sweep AI brings autonomous coding to GitHub issues, effectively creating a junior developer that automates basic bug fixes and small feature implementations. It does so by retrieving relevant code, planning edits, generating tested code with an LLM, and opening pull requests for review. Public reports and demos indicate that Sweep works best on narrowly scoped, well-specified tasks, like adding a function or typo fixing, and underperforms on broad refactors or ambiguous problems. Teams using Sweep typically gate it with human oversight, only trigger it on labeled issues, and have experienced engineers review each PR. They also monitor the bot's output through normal CI checks and review processes. When used appropriately, Sweep has been shown to accelerate development by handling tech debt chores automatically, leaving developers free for high-level design work. For anyone, even non-coders, building a software project, Sweep can serve as an accessible way to get AI help. The barrier is simply writing down what you want in a GitHub issue. The next step for novices is to install the Sweep GitHub app on a test repo, label an issue, and watch Sweep generate a PR. From there, you can review the code, ask the bot to refine it via comments or its Slack integration, and gradually gain confidence. In this way, AI truly unlocks coding by turning plain English tasks into ready-to-merge code, and empowering teams to focus on the creative parts of building software. Tags: AI coding assistant, GitHub automation, issue to PR, code generation, software development, LLM programming, dev automation, Sweep AI, junior developer AI. All links to sources are available in the text version of this article. You can find the full article at easycoding.tools. Thanks for listening. For more practical AI coding guides, tool comparisons, and resources for builders, visit easycoding.tools. And if it's easier to remember, just go to aibuilds.it. It redirects to easycoding.tools.